All right, so what I'm going to do now is create a little test case for our show message function right now that isn't being called anywhere. That's why it's grayed out like that. So let's just call show message and give it a test type message in some kind of test duration, whatever. Let's say 2. That would be like, in theory, 2 seconds. And this will get called as, in start. And so we can see what it does right now. So my assumption, if I save and go over here and run the game, so I made a bad assumption, and I assumed it would just change the message to this and it would be there forever because we haven't implemented that, right? The problem is we have the canvas group alpha set to 0. We need to make sure we make it show up. So we'll say canvas group dot alpha equals 1. Normally I wouldn't want to have magic numbers like 0 and 1. But in this case with alpha, it's clear that like 0 is invisible and 1 is visible. So I don't really feel the need to make variables for those. This would definitely be a magic number, but it's just placeholder. I'm going to get rid of this eventually when I'm done testing. So let's save it. Let's test it again. Oops. And it says testing like we had anticipated. Now what we don't have is a way for the message to go away. So I could just down here say canvas group dot alpha equals 0. So we would think about this like as we're going linearly line by line through our function, which is the way that it works. Line 23, turn on the message so it's visible. Line 24, change the text. Line 25, make it invisible again. What's missing is wait for the duration, then make it invisible. So because computers are so super duper fast, it's going to do all this like instantaneously seeming in terms of like my human perception. So now if I run the game now, even though there is maybe a moment in time this data is saying what I want it to and visible, it's actually not enough of a moment in time that I can perceive it. So in fact, it's all probably in the same frame anyway. So basically this won't work. What we need is a way to deal with timing more precisely. Like I need a way to go through this list and like right here, we want to do something like wait for the duration and then do this one, right? So by default in C# in a regular function, you can't do this. There is a way to do it with asynchronous functions in C#, which is now technically supported in Unity. But rather than go through that, I'm going to show you the traditional way of handling this in Unity, just because I think it's more robustly supported and we don't want to worry about weird, fringe cases that may or may not work, and I've never tried it. So we're going to use the thing called coroutines, which is our trusty standard way of dealing with asynchronous programming in Unity. And so the way to do a coroutine is, rather than saying it's void as the return type, meaning there is no return type, we need to change it to an enumerator. You have to be careful because there's a thing called an enumerable and an enumerator, and just basically I think it's enough to just remember enumerator is what coroutines use. So that's all we really need to remember at this point. And the problem is, now that we've added this return type, there is an error because our function here is never returning anything. So we said we're going to return something called an enumerator, but there is no return happening. So with coroutines, what you're returning is basically the way that you signal to the game that we are done with the coroutine for right now. We need to go ahead and go back and update the rest of our game objects and then go back and check on the coroutine. So normally if we were to say inside of our any kind of code that gets executed, if we were to put a while loop in our Unity game, it would totally like freeze the entire game up, because the game would be stuck in that while loop forever. And as long as it's in that while loop, it's not going to be updating all of the rest of the game objects. So, the way the computer works is it's just calling update on every game object, going through the code one by one, and it's not actually doing anything at the same time. It's doing it synchronously one by one in a linear fashion. So what we need to do is so the problem is if we put that while loop in, it interrupts everything and it won't allow us to update the rest of our game objects until the while loop is done, and it would just essentially make it look like your game has frozen until the while loop is done. So the solution to that is what's called asynchronous programming, and that's what coroutines do. So the coroutine allows us to execute it line by line like we would, but then essentially pause and tell the engine to go ahead and update all the rest of the stuff and come back here on the next frame, and then we'll go back into our separate sort of update loop. So when we create an IEnumerator coroutine, we're basically creating a parallel update loop that's happening asynchronously from the main update loop. Basically, in layman's terms, what that's going to let us do is do things like timing really easily. So all we need to do now to wait for the duration is we can say yield return, and then so this is just, you can think of it as the syntax of how we return in an IEnumerator. So what we want to return is a new wait for seconds, and we can just put in how many seconds we want to wait, which in this case is called duration. We're going to pass that in as a parameter. And now what's going to happen is when we execute this coroutine, we'll do this, we'll return this new thing called a wait for seconds, which is just something built into Unity that says pause on this IEnumerator, go ahead and wait for this amount of time in seconds, and then come back and do line 27. So it's very, very handy. It saves us from, like, in our update loop, checking, incrementing a timer and checking if time.delta time plus whatever our timer status was is greater than some time limit, then do the thing, and then not doing that when we don't need to. That's normally how you could do this in a regular update loop pattern. IEnumerator makes it, like, the syntax for this is very clean. It reads clearly. We do this, we wait for this amount of time, and then we do that. So the next step here is we don't just call a coroutine directly like that. Instead, we want to do something like start coroutine and then open parentheses, just like you would any other method. You call your coroutine that you want to start, including any parameters you want to pass in, and then you close the parentheses and add your semicolon. So this is the syntax for creating a coroutine. And so now what will happen when we test our game is the message will show up for 2 seconds. So we'll turn the message visibility on, change the message text, wait for 2 seconds, and then hide it. Let's go ahead and test that out. And again, since we're calling this in start, it should happen like instantly as soon as we start the game. So it says testing. In theory, 2 seconds have gone by and then it went away. We can try it again. We can try it again with like a longer amount of time. Actually, let's try it again with 5 seconds just to make sure it actually seems like it's doing things. Oops. All right, save that. In theory, it should take a little bit longer to go away. And it's working. All right, I think this is a good chunk of progress. So next, I'm going to make sure I've saved everything here. I'm going to go into my GitHub desktop and leave a note about what we changed. So we set up a basic coroutine for the contextual. All right. So I'll go ahead and commit that, and we will push it. And now let's go ahead and stop this video, and we'll take care of what's next soon.